Brevard County Historical Commission Oral History Video Project. Interview with Sam Beddingfield in Titusville, Florida, 1/15/1994. Interviewer Nancy Yaseko. Equipment, camera Sony DXC M7, recorder Sony BBW 35. Cameraman Bob Gilbert. Copyright Brevard County Historical Commission, 1994.
Okay, I'm a native of North Carolina. I was born in the town of Clayton, North Carolina, which is very close to Raleigh, the capital city. And I went to school, elementary and high school, in the town of Clayton, in a very small school, 24 in my graduating class. And I went to North Carolina State and studied aeronautical engineering, breaking the family tradition. Everybody in the family was medical except me, and I was the youngest, and I decided I didn't want any part of the medical world, so I'd always been interested in airplanes and became an aeronautical engineer. And when I graduated from college, I went to work for the Air Force as a civilian in flight test, but I had managed to get a ROTC commission with the Air Force, and after about 6 months of working for the Air Force as a civilian, they called me to active duty, and I, in essence, replaced myself. I just went home, put on the blue suit, and came back doing the same job. And I did that for about 3 years, and then...
It was during the Korean War?
No, it was between wars, between the Korean War and the Vietnam War. This was 1956, 59. And that was about time the space program got started, so I left the Air Force and went to work for NASA at Langley. Went down to Langley originally just to see if I could get a job in flight research at the Langley Research Center, but they didn't have any slots, so they asked me to go over to talk to what they called the space people. And I didn't think like I knew anything about anything if it didn't have wings on it, but I went over, and the first person I ran into over there was Gus Grissom, who was one of the original 7 astronauts, and Gus and I had flown together in the Air Force, so Gus kind of talked me into coming to work for NASA, which was less than a year old at that point.
But he wasn't an astronaut yet, was he?
Yeah.
He was?
Yeah,
Oh.
he was, they had been selected, I guess, around May or so, and this was about September. So, and he talked me into, made it interesting, and I went back to my North Carolina home, and they called me on the phone, and I finally agreed to go to work for them. And I stayed at Langley. I was going to try to work at Langley and then go home on the weekends so I could take care of the farm or something, and but that didn't work out. They sent me down to the Cape on temporary duty in September of 1959, and I never did make it back. Stayed down on a permanent basis. And this was to come down to really start Project Mercury here at the Cape.
What was it like when you first came here? What was your impression of the area?
Well, the impression of the area was different things gave you different impressions. The odor on the river was certainly a very impressionable thing, especially here in Titusville. The security was very tight at the Cape. When I came down, NASA had a little office down at Patrick, and you checked in down there, and then quite a bit of rigmarole, it seemed to me, to get into the Cape area. And NASA only had a part of Hangar S. One hangar on the Cape was all of the facilities that NASA had at that point. We had, the motor pool consisted of one 1946 ton-and-a-half truck. That was the entire motor pool. So, and we started moving around, and G. Merritt Preston, who was my boss at that time, says, "Gee, we got to have some station wagons." And I told him I had a Hertz rent-a-card, credit card. So he says, "Good, go get some station wagons." So I had 3 or 4 station wagons checked out on my Hertz card. I felt the GAO folks would come get me any time, but they never did. So that was how we started our motor pool, was just with rental cars. And we had to get all of the, not only were we worried about how to check out the spacecraft, but we had to get all the facilities and all the ground support equipment in place to start the project. And in the meantime, they were trying to launch some of the test vehicles. They had one shot called a Big Joe, which occurred just about the time I got here. And then we worked on a mission called MA-1, Mercury Atlas 1, which was a production spacecraft chassis, but none of the electronics were production. And we launched that. We worked for a long time. It seemed like trying to get it ready, and we launched that, and it lasted 51 seconds, and the rocket blew up. So, and it was raining terribly, just terrible weather when we launched it. And it fell in the ocean, and we got it back in about a day or so, and got to examine the thing. Apparently, the adapter between the spacecraft and the Atlas booster had failed structurally, and that's what made it blow up.
What was it like out at the Cape? I guess NASA had a little corner, but what was going on in the rest of it?
Well, there was an awful lot of there was a big push to get the ICBMs and the ballistic missiles working, not only ICBMs, but the intermediate range missiles too. And that was an impressive thing, was the street names out there. You have ICBM Road and IRBM Road and Heavy Launch Road. They were very functional names for the streets and roads out there. And everything was centered pretty much around the Launch Control Center, Mission Control Center, and they call it, it wasn't Mission Control Center, just Control Center, Central Control, that's what it was. And that was where all the destruct system, the flight safety officers and range safety officers were centered. But it was a very busy time. We would be launching like 3 a day. The U.S. would be launching like 3 rockets a day, frequently, which is quite a change from now, when they say they need 48 hours just between each launch. And they didn't have anywhere near the computers then that we have now. I guess they had more people or something, but the launches were very frequent, and frequently very interesting, because a lot of them didn't work. They would especially some of the newer machines, you had some spectacular explosions, even some of them right on the pad, and then you get off the pad. So that was a very interesting time to see the different vehicles that were going. There was a very active Atlas program. The Titan program was active. The Thor intermediate range program was active. Polaris was active. And there was some of them that you would always know what's going on. They called them by test number, but everybody knew which vehicle it was. And like the Polaris, everybody went out and watched the Polaris, because you weren't really sure which way it was going to go when it was launched. And especially after they lit one, and the second stage immediately lit right on the pad, and the second stage fell in the Banana River right near the Hitching Post Trailer Park, just in the town of what's now the town of Cape Canaveral. It flew southwesterly rather than southeasterly, and hit in the river out there just beyond the trailer park. So everybody went out to watch the Polaris when it went.
I guess so. Would you know the guys that were working on the different projects? Did they all do?
We knew a lot of them. You'd see a lot of them, you know, where we got into, we were all fairly young people, so the JCs was a big organization, especially here in town, and you got to know a lot of the guys through those kind of organizations. Work-wise, you didn't get to see, like the guys working on the Titan, and with me working on the Mercury spacecraft, we didn't get to work together very much. The range support people, the guys that worked for Pan Am and RCA and Technicolor and those people, you got to see them, especially a lot of the Pan Am people, because that was all the minor range support. And you got to see those people, but for flight hardware people, we really didn't intermix that much in the early days, because they were military programs and frequently very classified, and we were down with a supposedly unclassified program where we didn't have to worry too much about security. But you did get to meet them out in the community some. And there was, in the early days here in town, you had almost two cultures. You had the space people, which was one culture, and the Florida crackers, the people who had been here, which was another culture. And they didn't mix well at all in the early days. Some of the Florida cracker people who had been very influential in their community all of a sudden were not influential anymore, and there was quite a bit of hard feelings there for a while, but that finally got straightened out. And it was the area was growing so rapidly, it was hard to keep up. I know at one time here in Brevard County, we needed a new classroom in school every other day. The population was growing that rapidly. So it was very difficult for them to build the schools fast enough just to keep up with the population. And it was, and you couldn't, there was not, the infrastructure was not here. You couldn't go shopping. You couldn't go, everybody had young babies, and you had to go to Orlando to buy diapers. You couldn't buy those locally. The Sears store was a catalog store. There was one shopping center, Bird Plaza in Cocoa. That was the shopping center. And didn't have one on the beach, no grocery stores or anything. So lots of motels and bars on Cocoa Beach, but not no grocery stores.
Well, after a lunch, or even after a work day, would y'all stop at some watering holes? And
frequently there was some watering holes that were, see, in the early days, the Merritt Island was Merritt Island, and it was not Kennedy Space Center at that point. And out very close to where pad 39A and B are the shuttle pads, there was some pretty good watering holes along there. One place used to be called the Blue Whale or something like that, which was along Titusville Beach, which is just south of Playa Linda Beach. And there was some good watering holes to stop there. Down on Cocoa Beach, there was quite a few places down there. The Mousetrap was one of the ones that was known worldwide. In fact, the Mousetrap burned, and they were rebuilding the place, and it was so popular with the headquarters people that we had to put an item in the daily status report on the progress of rebuilding the Mousetrap so they know whether they could come down and visit the Mousetrap or not.
well, that was an important place for people to get together. And
Oh yeah, and it was an important place to go relax, because it was, it was pretty, the work was pretty tense. You were pumped up quite a bit. We knew we couldn't make a mistake. There was no books to go by. Our generation certainly had a unique opportunity in that there wasn't anybody around to tell us how to do it. We had to write the book as we went along. And today, the young engineers that are coming along have got old guys like me to tell them, well, you can't do this or you can do that. And I don't think they have the same opportunity we did. We knew we could make mistakes, but we couldn't make the same mistake twice. And so that's a big difference.
how would you feel when something you'd worked on for a long time launched and it blew up for some reason?
Well, it was a big disappointment to have it blow up, but the main thing was you learned something. Anytime something failed, you really learned something from it. The biggest embarrassment was if you ever had the same failure twice. That was just unacceptable. And so most of the time, if you had it so that it failed and it was the first failure and you really learned something, then it was some consolation because you learned something. But if you ever had it so that it failed twice, there was no excuse.
So there was no penalty for failure as long as
No, there was no penalty for failure or anything. And if somebody did something wrong, you stand up and say, hey, you know, I did it, and we try to understand that part, and that was it. But if you really didn't want to do it twice, though, because the peer pressure was almost unbelievable if you'd made the same mistake twice.
Well, I heard that nobody wanted to stop a countdown either.
Oh, that was a great game of chicken, I would call it, in that everybody would wait for somebody else to call a hold, because you always knew somebody's going to have a problem, and it was always who could wait the longest to call the hold, especially between the range people, the range support people, the booster, the spacecraft, and then you got all of the various systems of telemetry or power or fueling, cryogenics. And yes, there was always a great debate about who was going to call the hold. And as soon as somebody called a hold, there was all kinds of people that had problems to fix. But you didn't want to call it.
You'd be looking around the blockhouse and...
Oh yeah, you were watching other people's consoles to see how many red lights they had going. That was always, in fact, that still goes on today. So that's not anything new. Is who's gonna call the hold.
Take me through what a day would be like that was a countdown day.
Well, a countdown day was not, say, one of the normal days out there, especially like during Project Mercury. A countdown day would start. The first thing we did to the spacecraft in a countdown day was we installed the igniter and the escape rocket. And we did that with just 3 of us. Everybody else was in the blockhouse with the door locked, and we would go put I was the engineer, and we had a contractor technician and a NASA inspector. And we'd go out and put this igniter in the escape rocket and then check it electrically, which means putting electrical current into the thing to make sure the bridge wires were still proper, and then hook it up to the spacecraft. And then there was a ballast assembly that had to go on the top of that, which is a steel thing that you had to put in with about 8 bolts. And that would be the first thing that you would do. And once you got all of that checked, then they would start checking all the other systems, and as you get down later on in the count, you'd start putting the propellants in, especially like in the Redstone, the alcohol that was the propellant we used. That had been in there for days, but then you'd have to put the liquid oxygen in, and we were kind of casual about the liquid oxygen. Usually when they got ready to put the locks in, somebody would mention, well, we better stop smoking now, because we had a little room at the bottom of the gantry right there, and everybody was sitting around and that, and they say, well, the smoking lamp is out now, so we'd have to quit smoking. And it was pretty casual about sitting right by the bird while they're putting the locks in. And some of the safety things that we know a lot more about now were not as tight then as they are now. And then the count would be a long count. It would be, of course, with the shuttle, it's a 3-day count, but they have different shifts of people to come in. We didn't have that luxury. We only had 1 crew. And the count may be 24, 29 hours long, and you work the whole time. And if your system wasn't being worked on, you'd try to go find some corner to crawl up in and see if you could nap or relax or something. But other than that, you stayed out there the whole time. And
how many guys would be out there?
Oh, on the spacecraft, we'd probably have less than 100. And the launch vehicle, maybe, I would say the whole launch crew is probably no more than 150 people. It took more to launch the Atlas than it did the Redstone. It's a bigger rocket and more complicated. But it was not that many people compared to the hundreds it seems now we have to launch the bigger Saturns and shuttles. I've got a picture somewhere around of what we call the pad crew, and it's must be 15, 20 guys, and that's it for the Mercury out at the Redstone pad. So it was fairly small, and everybody knew everybody else. Everybody was on a first-name basis. We didn't. A lot of the communication system was literally just sticking your head over the side of the gantry and hollering, rather than using all of the operational intercom system they had.
Well, the pad wasn't very far from the blockhouse, was it?
No, especially not at the Redstone pad. It was very close. And
Like, how far would you say?
probably no more than 300 feet. Had windows in the blockhouse too, in the Redstone. You could look out the windows and see the bird. In fact, that was one of the things, the liftoff procedure was we had some of the Germans who had been around it enough that they looked at the color of the flame. And if the flame was the right color, it got launched. So just a real judgment call there. Now, in the Atlas blockhouse, you didn't have any windows because the Atlas was a lot more energy involved in the Atlas, much bigger vehicle. And the only way you could look out of that was with periscopes. And it's pretty tricky during the count on that because both of them, they had big, massive doors on the blockhouse, and the doors would get locked when they got, like when you'd armed the destruct system and those kind of things. Then the door was sealed, and unfortunately, the restrooms were outside the sealed door. So if you had a hole after the door got sealed, it really got to be sporting in there. So.
I think was the longest they ever went after they locked the doors.
I don't remember because fortunately my job kept me outside. I was the pyrotechnic system engineer, and I was back at what they call the roadblock. And my job, if the thing crashed, was to go safe all of the explosives. So I didn't have to stay in the blockhouse during the Mercury and Gemini flights. I was back at the roadblock. That changed later on with the shuttle days when we had the Launch Control Center, and I did get stuck in the firing room for that. But during the early days, we were back at the roadblocks, which you had to fight off the mosquitoes and things, but you weren't stuck inside the building.
But you were still pretty close to the pad even at that. I mean, you must have had some concerns about the safety of
the first production spacecraft we tried to launch. In fact, that capsule is out at Spaceport USA right now, and it was on what we called MR1, Mercury Redstone 1. And when the engines on the Redstone lit, the vehicle lifted off about 2 inches, and then there was a relay race because of the way the tail plugs came out, and it shut the engine down, so the vehicle just sat back down. And the escape system was being flown kind of open loop, and it was looking for a signal from the engines that the engines had shut down, and which meant that everything was okay. So the escape rocket fired its bolts that held it in place, and then the rocket ignited, and the whole escape rocket just took off. And it had about 52 G's acceleration because it had 52,000 pounds of thrust, and it only weighed 1,000 pounds, so it took off in a big hurry. And we were back at the roadblock, and didn't really know what went on. Everything happened real quickly there. And one guy commented and says, "Boy, that thing's faster than Swish," and that was his first rocket launch. And one of the old mechanics who'd been watching Redstones and everything else for many years, he says, "Yeah, but it's got to come back down." So he crawled under a truck. And the escape rocket did indeed come back down, and it hit about 300 feet from us. It went over 35,000 feet high, straight up, and then came right back down between us and the blockhouse. And I imagine distance-wise to the blockhouse, straight line distance was on the order of a half a mile or something like that. So, but it did come back pretty close.
That rocket had a series of problems, didn't it? Didn't it shoot off its parachute?
Well, yeah, what happened, it went right through the whole sequence. There was a sequencer in there, and the spacecraft sat there and did everything it was supposed to do except one thing, which is very fortunate. It did not fire the retro rockets. If the retro rockets had fired, that was right into the fuel tank on the Redstone, and we'd had a catastrophic explosion. But there was a switch in there, which they used to call a quarter G switch, and that was the arming thing for the retro rockets, and that didn't get armed. But everything else, it dumped the peroxide like it was supposed to. The main parachute was deployed. We had a sensor in the parachute, so if it didn't sense a load on the line, it would disconnect that parachute and deploy the reserve chute, and it went right through the sequence, did everything it was supposed to do, except we then had the rocket sitting out there not held down at all with a 63-foot parachute draped over the side. Fortunately, the wind didn't blow, so it would pull it over, and the destruct system armed. The umbilical system was totally disconnected, so we couldn't disarm anything. So they finally decided the best thing to do was wait for the batteries to run down, and so we just absolutely shut the whole range down for over 24 hours, waiting for the batteries to run down so we could go do something about it. It was.
Well, that didn't happen twice.
No. That was, what happened, it was the Redstone that was the problem, not the spacecraft. And we had, two bunches of people there. We had the spacecraft crowd and you had the booster crowd, and quite a bit of competition between the two. And I know I went back out there one day with with the escape rocket to install it again, and one of the booster guys had some snide comment about my escape rocket, and I quickly told him, I said, "Hey, last time my rocket worked, what happened to yours?" So it was that kind of competition that went on all the time.
It was different, though, when there was a man in it, I guess. Huh?
Well, yeah, it was. We launched some Mercuries without men in them, of course, but then it seemed when you got to the point where you started putting people in them, you were just a little bit more careful, I would think. And of course, the astronauts were just part of the crew that was out there. We worked with them every day, so we were working with the crew all the time. Yeah, you got a blinking light.
Okay.
Do you hear this?
Now I do. I didn't hear what was on your headset. Video. Interviews Sam Beddingfield, Titusville, January 15th, 1994. Interviewer Nancy Asseco. Camera Bob Gilbert. Equipment. Camera Sony DXC M7. Recorder Sony BVW35. Copyright Brevard County Historical Commission, 1994.
Okay.
Roll.
Okay, this is the escape rocket that I was talking about. This particular picture here is I treasure this because the original 7 astronauts all autographed it and sent it to me unsolicited at the end of the Mercury program, so I keep this one on the wall. Don't do many on the wall, but I do keep this one. But this is a good picture of the escape rocket. And this ballast assembly is up here on the top. There's a called an aerodynamic spike on the top, and the igniter had to go into the very top end. And when the Mercury Redstone 1 mission tried, the escape rocket separated here, and the whole assembly took off. And then the spacecraft sat there and went through all of its systems. The antenna can came off, the parachutes came out of that. There was peroxide reaction control motors in there that dumped all the peroxide. And fortunately, the retro rockets down here in the retro pack did not fire. So it was we were pretty pleased because we got a good test out of it. The spacecraft did exactly like we had planned for it to do. Then we brought it back to the pad, back to the hangar, and worked on it again, and finally did launch that same capsule. And that capsule is now on display out at the Spaceport USA. That is the Mercury spacecraft that's on display out there.
Tell us a little bit about each of the 7 astronauts. I know you worked with them in various ways.
Yeah, they well, they're all 7 of them were real sharp guys. Each of them had a large ego, I guess is the best way to say it. Very competitive with each other, but supportive of each other too. But among themselves, they're very competitive. They would look for anything that would give them an edge over one of the other guys. And they worked with the launch crew very closely. We spent a lot of time with them, especially some of the work that I was in where we had to do a weight and balance, and the spacecraft had to have the weight and balance, the center of gravity, determined very precisely, because the rockets, the retro rockets that I talked about, and then the separation rockets, which we call posigrade rockets, had to fire through the center of gravity or the spacecraft may tumble. So for that purpose, we just considered the astronaut another piece of equipment. And he had a part number, and we physically weighed and determined what the astronaut's center of gravity was. So, and it was to make him fit into his helmet, and the helmet into the contoured couch and everything. We even had them have their hair cut the same way each time. If the time that we had weighed them, if they had had a haircut 3 days prior, then we would want a haircut 3 days prior, so everything would fit precisely. We were probably way too conservative in most cases, but we didn't know any better, so we did it that way.
We really didn't know what would happen when a man went up.
No, there was a lot of people that says people couldn't survive in space, that they would the re-entry stuff would kill people. So, and a lot of G-forces that the Mercury program, we were running 6, 7, 8 Gs. So I don't know whether you've ever flown with a lot of high G loads or not, but that's not a very pleasant experience. Most airplanes that even fighter planes that you maneuver in, 4 or 5 Gs is about all you do, and you're taking that up the backbone and not this way. The expression we used was eyeballs down or eyeballs in. So, we used. There had not been a whole lot of research on eyeballs in G loads, and there was some concern as to whether people would survive that or not. So that was one of the major goals of Project Mercury, was just to see if man could survive in space and do some limited maneuvering. And then we went to the Gemini program, and the Gemini program was very specific to see if he could maneuver a spacecraft and maneuver and also rendezvous. We had to do that in order to make the Apollo program work.
Thinking of that reminds me of when the commitment was made to go to the moon, you were already underway with Project Mercury. Alan Shepard had flown, so you knew.
Yeah, we had 15 minutes of manned spaceflight experience. 5 minutes of weightlessness was all we had when the president committed us to send somebody to the moon and back safely. And safely was the word, because that was you had to have it right, because once you launched and went on the translunar trajectory, or practically just got into orbit, there was no rescue capability. They were kind of on their own resources, and I think one of the most dramatic things in the whole space program was the Apollo 13 flight, where the oxygen bottle did indeed blow up, and the amount of work that was done in order to figure out how to get that back was a tremendous cooperative effort between the people on the ground, and it was people on the ground all over the country, and the crew and the spacecraft. The thing was practically redesigned during that flight, and we were dependent on one engine to make sure that it would fire to get the vehicle back in one piece. That was a very dramatic thing, probably the most dramatic thing that's happened in the space program. I don't know how much the general public understood just how critical that was, but that was a very dramatic thing.
When we were just getting started, we didn't know so much. All these astronauts, they were all ready to go, though, weren't they? I mean,
Oh yes, they were all test pilots, and all of us that had been in the test flying business understood that there were risk involved, great risk, and I guess all of us that have been in the airplane testing business have had friends that ended up as smoking holes in the ground, and that's part of the territory. You try to, you don't want that to happen, but it's all machines, and you cannot make a perfect machine. And it's unfortunate that you don't have much rescue capability with spacecraft.
No, that's still true.
We had the Mercury did have the escape rocket, which would pull it all off in one piece and then open, and the Apollo was built that way too. Now the Gemini had ejection seats in it, and the ejection seats were not usable except on a very limited period of time.
Yeah,
they just had a few seconds at the start of the flight and after re-entry that the ejection seats would have been usable. So it was a pretty sporting thing to use that too. In fact, most of the time if you used it, you'd probably end up going through the fireball of the exhaust. So.
Yeah, I guess nobody wanted to use it.
No. And you got 22 G's up your backbone. That's eyeballs down if you fired the ejection seat.
Cut for a second.
God damn. Okay, you ready?
When that commitment was made, it really put a time frame on things, and all of a sudden there was a real big hurry to get stuff, and they brought in a lot more people.
Oh yeah, the number of people working on Apollo ended up all over the country, it being about 400,000 people. So, and that was, as I said previously, they needed a new classroom every other day here in Brevard County. Just the population was increasing that rapidly.
Did you have kids in school here? Or?
Yeah, both of my kids were born here and went through all the way through high school and UCF. So they went. In fact, it was the school system was rapidly expanding, and my oldest daughter, we lived in this house. She went to Whispering Hills School for her first year, South Lake School for her second year, and Apollo School for her third year. And we never moved the house. The school districts kept changing, and I got tired of that. So I finally called them up and said, "Enough's enough. We're not going to move anymore." So she stayed at Apollo School for her rest of her elementary. But there was a big buildup of people, and even before Apollo started, in my case, I worked very long. There was, 12, 15-hour day was certainly not an uncommon thing. And my wife was new to the area, and if the washing machine broke, she wouldn't know who to call or anything like that. And it turned out that one of the best sources of information in town was the guy that ran the gas station, Mr. Alton Threckle, who ran an Esso station downtown. And she quickly learned that if she had a problem, she'd call Alton and not call me, and he would tell her what to do. or send somebody over here to fix the washing machine or whatever it was that broke. So it was very interesting as to how the old Florida cracker community and the space workers started merging. It was an interesting problem, and that's pretty much when it really started getting together, was during the Apollo time.
They did build some more schools, and they built some more restaurants, and some grocery stores came in.
Oh yeah, when I first came to Titusville, there was, I think, 2 restaurants here. And one of them's still here, by the way. The Moon Drive-In was here then and still here now. That's the only one I know that's totally survived the whole time. All of the others have been built since then, and the 1 or 2 that were here then are no longer here, except maybe the coffee shop, Eula's Coffee Shop. That was here, I think.
What would you do for family entertainment on the weekend?
We went to the beach a lot. The beach was certainly available, and there was almost no parks or anything to go to, so you didn't go to the park. There was some very small parks and things, and a lot of weekends we just worked. It was not a lot of Saturdays and Sundays off. A lot of Sundays off. We spent a lot of people were pretty heavily involved in the church activity. But all of this working did take its toll on the family life. There was an awful lot of divorces, unfortunately, that occurred during that period of time because people were just separated too much. And there was a lot of travel involved also. I realized during the Apollo program that I had been going to Washington too much. When I got off of the airplane and went out to the taxi, and the taxi driver called me by name, I realized that I had been going to Washington too frequently, so I decided I better start sending people. So it was that took a lot of toll on family too, with all the traveling, because I would go from here to Houston, and Houston to Los Angeles, in Los Angeles back to Long Island, the Grumman plant in Long Island, and back to here, and do that once a week for about 6 months. So that was a lot of traveling.
What was your job at that time? What were you doing? That was the Apollo?
Yeah, I was running the systems engineering office, and what I was attempting to do was to make sure we got a good spacecraft shipped down here, because frequently we'd have all these big meetings which would theoretically turn the spacecraft over from the manufacturer to the customer, NASA. And everything seemed to be in good shape, and we got it down here. Then we'd get a Twix about that long and say, would you confirm whether the following EOs had been worked or not? And you knew that was the open item list. And all of the schedule was based on the fact that that work had been done. And after a couple of them getting shipped like that, I got tired of that, so we went out and said, we want to make sure that when you ship it, we know what work you've got to ship. So it was, again, it was kind of a game. Whose shift is it going to be on? Unfortunately, we had to finish everything down here. We couldn't pass it off to the mission control people.
So there were passing their problems to you? And
Oh yes, they would ship it down with parts missing and tests not done, and or if tests were done, not done correctly, and so. But unfortunately, down here is where it all came together, and you couldn't pass it on to anybody else. So we always got blamed for slipping the schedules.
yeah, they met their date.
Yeah, but it was good. And then in Apollo, especially the lunar flights, nobody could slip because there was only certain times of the month you could shoot to the moon, and then if you missed that launch window, you had to wait until the next lunar cycle came along before you could do it. About 28 days. So nobody wanted to cause that to happen.
During that time, I guess the first part of the Apollo, they were working on that first capsule, and of course there was the problem with the fire.
Mm-hmm.
What was your involvement with that?
Well, I had been the mechanical systems section chief, and the day the fire occurred, I was scheduled to leave the operations engineering and move to the program office. And the fire occurred on a Friday, and I was supposed to leave the working as a mechanical systems engineer and go to the program office on Monday. But one of the jobs that I had that I carried with me was to be in charge of the emergency egress working group, where we were supposed to figure out how we would rescue or take care of the crew in an emergency. And that was what I was doing at the pad that night, was waiting for the test prior to that to be over so we could practice some of our procedures on emergency egress. And that was, needless to say, a very traumatic experience, and because we found out that things happened so quickly that a lot of our rescue preparations were no good. We had to change rather drastically what we wanted to do, and we had to change even the design of the spacecraft in order to make them work. We couldn't get the hatch open, for instance. When the fire occurred, it was an outward opening hatch, an inward opening hatch, I'm sorry, and when it pressurized, when the fire started, there's no way to get the hatch open. So we ended up with the rest of the Apollo with an outward opening hatch, and as it turned out, that was a good thing to have, because we did start doing some EVAs with that, and it made it a little easier to do extravehicular activity with the hatch that swung open. But there was a safety consideration for a hatch that opened inward, because the pressure kept it in place, and you wouldn't worry about an inadvertent depressurization. The Russians had a hatch that came open during re-entry about that time, and they killed 3 of their cosmonauts because the hatch came open. And so there was always a trade-off on safety on how you did it. But since I was in a transition from one job to another when the fire occurred, I was just assigned to the investigating team to investigate the accident, and my job was to take the spacecraft apart, to be in charge of that and make sure that we didn't destroy any evidence while we were doing it. And it took us about 6 months to do that before we finally got everything taken apart and the burned spacecraft taken care of. We were concerned. That was when the Freedom of Information Act first came into being. And Dr. Thompson, who was the chairman of the investigating board, told me, he says, "Sam, I want you to put that spacecraft, we have to keep it for 10 years for evidence. And he says, but I want you to store it in such a way that it is difficult but not impossible to get to it." So we went up to the Norfolk area, and we found some buildings up there that they had been storing airplanes in. And we cut off about 40 feet of a building and put it on a barge, a metal building, and brought it down here by barge. We put the spacecraft in it. We sealed the ends, and there was about a 3-foot by 3-foot door that you could go in. We filled the entire building with nitrogen, put it back on the barge, and sent it back to Langley. And then we wrote a procedure that says if you want to go in the building, you must have current Scott Airpack training. And the only place you can get that is at Kennedy Space Center. So you had to come down here and get trained, because if you go in the nitrogen environment, you drown. And you have to pay for the nitrogen that's lost while we do it. And I figured that was difficult but not impossible. So spacecraft stayed there. And after 10 years, I finally got off the hook. So I'm not sure where it is now. There was some discussion about bringing it down here and making a memorial or something out of it, but I don't think that happened. Last I heard, the thing was still at Langley.
Well, I guess there were a lot of things that had engineering solutions, not unlike the one you've described. You know, trying to solve a problem or getting all the elements together. Let's see, talking about the Apollo mission, you mentioned Apollo 13. You were here in the area when Apollo 11 went up.
Yes, I was working on Apollo at that time. In fact, right after we got the guys back to Earth and they were recovered, I left on vacation. And I'd been on vacation about a week, and I got a call to come back to work to start working on the space shuttle. So I did not get to follow the Apollo program. We had dual duties there. We were doing some shuttle and some Apollo, but as the Apollo program started winding down, the shuttle program got more and more involved. So I mostly started working on the space shuttle 25 years ago. So right after Apollo 11.
It was about that time a lot of the guys who had been on the team, you know, from Mercury to Gemini and Apollo, you know, more and more people all along, but they began to lay off a lot of people.
Yeah, we lost an awful lot of guys. I especially, you know, you got to admire like some of the Grumman guys, because Grumman had the lunar module contract and they had no other contract down here at all, and like Apollo 17, they knew it was going to be the last flight, but they worked just as hard on that as they did on the first one, and then know when that flight's over, they're going to be out of a job. And it was all a direct result of the budget situation. The budget started getting cut really about 1967 is when the budget started dropping off rather drastically, and if you convert it all to some constant buying power dollar, that it very rapidly got to the point where the budget was about the same level it was in Gemini, and it stayed that way until about the time of the Challenger accident, where it peaked up a little bit to fix the Challenger accident, and has increased a little bit since then, but nothing like it was in Apollo. Apollo was a program that was done from an engineering standpoint, done really correctly, where the technique we used was to take each component and qualify that component in the environment it was going to see, and then put all the components together and make sure they would work together. We didn't get a chance to do that on the space shuttle. That takes a lot of upfront money to do, and we didn't get the upfront money on space shuttle. So what we had to do was to put all the components together and try to qualify something and see what broke, and then go back and fix it. And that's a very expensive way to do it, especially with things like space shuttle main engines, when you may put it all together and have one line or something break, but it would then destroy all the expensive turbo machinery and those kind of things. So that was, if it works, you save money, but if it doesn't work, it really adds to the cost and schedule.
So there were really different ways of operating
Yes.
after Apollo.
In Apollo, we practically had a sign chiseled in the sky, waste anything but time. In the shuttle program, we had a schedule that we wanted to meet, but we also had a design to cost. The designers were given a cost bogey to design. Everybody has to design to a weight bogey normally, but not only did they have a weight bogey, but they had a cost bogey that everything was supposed to be designed to, which was a new thing that had not been done. And everybody would try to cut every corner they could to keep that cost within their assigned number. I don't think that it made it unsafe. It just was a different way to do it, and was not, to me, as effective as the Apollo system.
Well, isn't that the way they do with like production aircraft? Things that they sort of know what they're doing with,
They can kind of do that, but when it's pushing the state of the art, it's very difficult. And we really pushed the state of the art in the shuttle program, especially in three areas: in the computer area, and in the heat protection system, the thermal protection system, and the main engines, the propulsion system. The shuttle, space shuttle main engine is about a 3,000 psi pounds per square inch chamber pressure, where most rocket engines, Atlas, Centaur, those kind of things are only about 750 pounds per square inch to 1,000. So it's a real advance in the state of the art on how that engine works. A very, very efficient engine. If the engine in your automobile was as efficient as the engine on a shuttle is, your engine in your car would weigh about 3 pounds. So it's a very efficient engine. And we had to really push the state of the art in order to get that on the shuttle. And the thermal protection system, the tiles, we had 2 or 3 ways we were trying to go on that, and you got a blinking red light.
Yeah, that I hear.
About 30 minutes.
You hear that?
We got a couple of minutes.
Okay.
We can-
All right. The thermal protection system, we had 2 or 3 ways we wanted to investigate. We did not have enough money to thoroughly investigate all of them, so we had to just pick one, and the tiles seemed to be the most promising, so we picked that one. And we didn't get to investigate the others like we would like to.
So there was the engine and the tiles
And the computers. We had the computers we didn't really get to build as new a computer as we wanted to. In fact, the shuttle has, up until very recently, had some pretty lousy computers in it. You know, a lot of the 767 aircraft that everybody flies around for an airliner right now has far superior computers to the shuttle, until we managed to change some shuttle computers recently. But the shuttles were computers, the old AP-101s, were kind of antiques. They didn't come out of Noah's Ark, but close.
Yeah. All right, let's go ahead and swap. Okay. This is the Brevard County Historical Commission's Oral History Video Project. Interview with Sam Beddingfield, Titusville, Florida, January 15th, 1994. Interviewer Nancy Asecco, cameraman Bob Gilbert. Equipment, camera Sony DXC-M7, recorder Sony BVW35. Copyright Brevard County Historical Commission, 1994. I know no day was typical, but maybe you could just try to describe what it was like. You know, you got up in the morning.
Well, one important thing out at work was to always make sure that the coffee pot worked. And when you get to work, and if something was wrong with the coffee pot, everybody stopped everything else to go fix the coffee pot. Then you get the coffee pot working, then you go do your other things. But there was no real typical day, because it would depend on where you were in the checkout sequence to make that day special. And we didn't work on just one spacecraft at the time. We'd have 3 or 4 of them, so it varied as to what you would do during the day even. But some days would be particularly difficult, like the Mercury spacecraft had the heat shield disconnected and dropped down about 4 feet to make a landing bag, so when it landed in the water it cushioned some of the landing shock. And it was some very, very tight criteria as to what kind of gap there could be around the heat shield when it was latched up. And it was very difficult to get that balance like it should be. And sometimes you would spend 3-4 days just trying to get the heat shield latched in place.
So it'd be like 2, 3, 4, 5 guys?
Yeah. And a lot of other people sitting around waiting for you to get through with that so they could go do their test. And you get very frustrated sometimes, because it would you get one side correct and the other side would be out of spec, and you go adjust that side, then the front side, the other side, was now out of spec. So there was a lot of that went on. There was a lot of where you would get ready to test something and the guy right in front of you, some component in his would break, and say, okay, let's go get a new one, and the new part wouldn't be there, and you'd have to wait for it to be shipped in from some vendor or the factory or something. So each day was different. We always had a meeting in the middle of the day, kind of a status meeting and change board meeting, where any change that was going to be made to anything, everybody had a chance to discuss it, so we would know when we were changing the configuration of something. And that was kind of typical in a Mercury. And the Apollo, it got to be a little bit more organized, and we pretty well worked on one spacecraft at the time. And the change board got to be, there was more things to worry about in Apollo, especially that there was many, many more ground systems and facilities and those kind of things where Kennedy was really responsible for them. And we had to make sure that if we changed something, that it did not affect one of the interfaces as to how it would make the spacecraft or rocket different. So there was a lot of change board meetings that got very formal so far as configuration control. In fact, that's what we called them, configuration control boards. And I ended up doing a lot of that, especially during Apollo in the early shuttle days, was running the configuration control board. And
would that be an actual board that had information on it? Or
no,
was it
it was a board of people. It was a meeting, and we had representatives from all the directorates and all the systems in there. It was a very dictatorial type thing, though. My vote, I listened to everybody, and everybody had a vote, but nobody's vote counted more than mine. So it was about the only way to do it, was to do it dictatorially, because everybody always wanted to change. At one time, we were launching the things within milliseconds of when we were supposed to launch it, and everybody kept coming in wanting to change. And I said, no, why should we change? We were launching within milliseconds. So then they came in and said, if we change this, we can save manpower, man-hours. And that sounded like a good idea. We're going to save money. And then I got to realizing we still got the same number of people here. We haven't really reduced any people. So I said, okay, I'll approve any manpower saving change as long as you bring me the man's name and badge number that's going out the gate. And that cut those changes out. Because engineers are going to engineer. Everybody wanted to change the thing, even though it was working perfectly. And So, and from a management standpoint, you had to do a lot of techniques like that to drive your point across. Because you just hated to sit up there and say no, 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 no all the time. So the thing was to try to do was to not get them submitted in the first place. It was a very formal process for changing things. It was it was a very bureaucratic system. You had a form you had to fill out, and lots of people had to concur on it. And then it finally there was a presentation at the board meeting which says this is what we want to do and why and how it fits into the budget. And my job at that point was to try to keep a balance between the cost and the schedule and the performance. Because a lot of times when you want to change something, it may not cost much money, but it could affect the schedule, which would throw things out of kilter. And so my job ended up being a systems engineering office was to try to see if I could keep those three things in some kind of proper balance.
Schedule was number one.
Yeah.
You lost some time redesigning the Apollo spacecraft.
Yes. We spent a lot of money too redesigning the spacecraft. As I remember it, the new hatch cost like $75 million. So it was we lost some time, but then we gained some time, and there were some rather innovative techniques where we did things like we wanted to. Remember, there was a stack where we wanted to fit things, and the second stage was late coming in, and they just made a dummy second stage, and we plugged that thing in so that we could test the first stage and the third stage, and then went back and put a second stage in when we got it and caught up with that testing. And there was a lot of innovative things like that to do. And I remember the Apollo 8 flight, which was Frank Borman's flight. That was the first one that went to the moon with Frank and his crew. And that was one that was fairly innovative. That was the first time we had flown a man on Saturn V, and we flew him to the moon. And we had no capability to land, of course, because the lunar module was not up to the same schedule that the Apollo spacecraft was working. So we decided that the best way to do it was to go ahead and test the Saturn V to its ultimate and the Apollo, and then catch up later on with the lunar module. And it turned out that it was a very impressive flight. But it was a big decision to fly that thing during the Christmas holidays. Back during Project Mercury, we were ready to launch John Glenn's flight, or we thought we were ready, like in December of 1961. And the president called up and said, do not fly it during the holidays. And as it turned out, we scrubbed enough that it was late February before we ever got it off. But we felt at one time, schedule-wise, that we could have launched that in December, which was an important thing to the launch crew, because that says we would then be flying in the same year that the Russians had flown. See, so as it turned out, we didn't get to do it.
What was the fear, that there would be a disaster?
That if it crashed, that the consequences during the holiday season would have been too great. At least that was my understanding. I did not talk to the president about that one, but President Kennedy was great for calling up and asking you what was going on. I got a phone call one time. I was out working on the escape rocket, and somehow in the blockhouse, somebody hit the PA system and said, hey, will that escape rocket work? And I came back with some smart answer like, who the hell wants to know? And they said, the President of the United States. So yeah, you really didn't know who you were going to be talking to on the phone.
Didn't realize he took such an interest.
I didn't either until that day. That was just before Shepard's flight. You wanted to know, would the escape system really work? Yeah, it's going to work. And that was in those days. The systems engineer was totally responsible for his system, which was a real unique thing. It's kind of done by a lot of committee action now, but it was a lot of individual basis. If you said it was ready to go, people took your word and said it's ready to go. If you say can't fly, everything stopped, based on one person.
Another thing that seems to have changed a lot is that in the beginning you were writing the book, and now there's a book 2 or 3 inches thick for each mission, huh?
Oh, yeah.
Procedure manuals are.
There are many standard operating procedure type books available now, and that's,
How are those developed?
a lot of them are developed based on experience. And when any procedure is written, somebody, of course, has to sit down and write it, and then it goes through many, many reviews. You have lots of interesting people, depending on how integrated the procedure is. If it's to check out just a widget, then the widget people get together and talk about it. And if the widget doesn't have to interface with anything else, then that's the end of it. But if it's an integrated procedure where lots and lots of systems are involved, flight hardware, ground hardware, crew might be involved, then the review process for that procedure is very long, very complicated. And in going from Mercury to Gemini and Apollo, we learned how to document things so that you didn't have a lot of trouble trying to go from one place to another. We had what we call ICD, which is an interface control document. And that was a very sacred document. That would be between like 2 centers, between, say, the flight hardware and the ground hardware. And we would define what the interface was going to be, and nobody could violate that interface. If you had to change the interface, then it took a new agreement to change the interface so that both sides would work. And that turned into an interesting process. In fact, I got a call one time from the he'll be out of the way in just a sec.
Background.
Yeah.
He's not obliterating the track.
Okay. I got an interesting call from the Army one day they were developing a new tank, and they wanted to build part of the tank at one place and like the turret and the gun at some other place. And we introduced them to the concept of interface control documents to tell them how to do that. And we had quite a few interesting meetings with the Army to show them what we were doing with the spacecraft, and they used that same technique to build tanks with. And I think that's one of some of the spin-off stuff from the space program. It's very hard for people to see a lot of the benefits, because the benefits frequently are what I call second or third order benefits. You can call up today and make an airline reservation pretty simply, and a lot of the computer programs that are used to do that are the techniques for those computer programs were developed in the space program because we had to develop them. And then you can take that technique and use it for something else. A lot of the reliability things were developed. We had to know what they were. Some of those things are good and some of them are not good. As far as a consumer is concerned, I think that we learned an awful lot of what we call mean time between failures. That is, how long something is going to last before it fails. Like an air conditioning compressor. Well, the mean time between failure on an air conditioning compressor must be about 61 months, which is 5 years and 1 month. So the manufacturers can guarantee the thing for 5 years, for 60 months, and know with about a 95% confidence that it's going to last 5 years. But after that, the probability of failure goes up pretty steep. So, and I don't know whether that's good or bad for the consumer, but at least the manufacturer knows, and he can use it certainly in his salesmanship that I'm going to guarantee this thing for 5 years. And he knows pretty confidently that it's going to last 5 years.
When you were keeping track of all of the components coming together and at what stage each one was in the process, did you use computer programs or did you have lots of paper?
We had lots of paper originally. The computers that we, like in the Mercury program, were very primitive computers, especially in today. You know, the biggest computer we had wouldn't have the same power that my personal computer does back here now. And we did an awful lot of it with just paper. In fact, even through Mercury and Gemini and Apollo and into Shuttle, it's been an awful lot of physical paper rather than electronic. They're now getting around to the point where they can keep track of a lot of it with computer and electronics, but there's still a lot of paper involved.
When I think about it, there must be thousands and hundreds of thousands of parts to keep track of.
There are many, and the problem is that these parts change. You know, you can have a particular valve, and you get a program that's been going on, say, as long as Shuttle has been going on, and the guy that makes the seal for that valve may go out of business. So unless you can find somebody else to build that seal to that original spec, then the valve has to be changed. So then you've got at least a different dash number or something you have to account for. And you've got a new qualification program. You may have to go back and requalify that valve because it's got new components in it. And you have to keep track not only of how it's made, but what its qualification status is also. And go back and see what all the spares are. How many of them do you have on the shelf now that are no good?
It takes a lot of guys to do that.
Yes, it does. The logistics of a program that has been in existence as long as Shuttle. Remember, I've been working on Shuttle for 25 years, so Shuttle is an old vehicle. And just the logistics of trying to keep all of that straight is one of the most all-encompassing functions of the program, just to try to keep the thing flying. That's one of the things in the Shuttle program that has been underfunded rather severely. And I think the classic example was we landed a shuttle out on the KSC runway, and they went out and took the nose gear steering box out of the vehicle while it was still on the runway to go put it in another shuttle so they could close up the front end and hopefully get it going to the pad. They didn't have enough nose gear steering boxes to even have a spare. And so they took the one that had just landed and put it in an oven before they even got it off the runway. So
They were probably waiting for it to come.
they were. So, and you know, it was like the spare parts or logistics world has been funded at about 15% of what it should be. So, but there again, you have to use some judgment on that. If you kept enough spare parts so that you never had to wait on a spare part, then you're going to end up with a lot of spare parts on the shelf you never use. Wasted money. So it's kind of a delicate balance, and that's part of the kind of the non-glamorous part of the space program, just in the spare parts business. But it's a very, very important thing, and the only time you ever hear about it is when the system doesn't work. When you're out on the pad and they can't close the hatch because one bolt's missing and they can't find a new bolt. If they found a new bolt and just put it in, you never heard about it. The only time you ever hear about the logistics guys is when their system breaks down.
Well, I think that's true overall in the program too, because there's a lot of, you know, failures that are remedied before a bird is launched.
Yeah.
That nobody hears about.
Okay, can you stop?
Okay.
Next question.
5. Can you tell me, you know, engineers have their own sense of humor. These pad rats did too.
Yeah, there used to be several things that we would do. One of the ones that comes to mind right now is take a hard hat and fill it up with Freon. And you'd be up, 100 feet, a couple of 100 feet high on the gantry and see somebody walking down on the pad surface, and you lean over and say, "Look out below," and dump the hard hat, because it looks like water coming down. But about 10 feet before it gets there, it all evaporates into the atmosphere. Now, we probably contributed to the hole in the ozone or something, but that was a great joke, was to dump Freon to see everybody run to keep it from hitting them, and of course it never got there. Did a lot of those kind of things. We would take pictures of people with ultraviolet light and use black and white film, and it ends up showing the skin pigmentation rather dramatically and those kind of things, which were kind of fun to do. And we didn't have a lot of time to do a lot of them, but there was a lot of humor involved, especially like when Al Shepard really he was really enamored with Jose Jimenez, Bill Dana's reluctant astronaut, and part of that astronaut routine, he wants his crayons, and so for Shepard, when Shepard came out to go on his flight, I had a box of crayons and gave them to Shepard just before he was getting in the elevator to go up on his mission. And on Wally Schiral's Mercury flight, Wally was a great sports car enthusiast, so the hand controller had to have a locking mechanism in it, so when the crewman got in, he didn't hit the hand controller and fire some of the attitude control rockets. So normally you had just a pip pin that you put it in. So we took the pip pin out and we went down to Jim Rathman's and got an automobile ignition lock and substituted that so that we could, and had a very fancy key that you could do. So when Wally got in, we told him, "Okay, we've got this thing tuned up like a sports car." And he took that ignition lock later on and put it in his own car. So we did a few things like that. I can't think of any other specifics right now, but it was not all seriousness.
Well, when you work that hard, you needed some relief from the tension, I guess.
Yes.
And that would have been true all the way up the chain.
It was always great fun, especially when you would get like a new secretary down or something, and you would tell her, "Look at that rocket out there. It's got those black and white stripes on it, and watch it at night, because if the light's shining on the top, they're going to launch it pretty soon." Of course, that was the lighthouse, and it was they'd stay up all night waiting for this rocket to go. It's not going to go. And I'm sure you've seen some of the films where we've superimposed the rocket exhaust underneath the lighthouse and launched the lighthouse and those kind of things.
What would y'all do with that film? I know it was called The Lighthouse That Never Failed.
Yeah.
When would people watch that?
At parties and those kinds. A lot of times you'd have a party after a launch or something, and then somebody would show those at various parties and reunions, those kind of things. I have a film back there in my desk called Our Toys Make Noise, and all it is just one rocket after another blowing up. But that's the title of the film, Our Toys Make Noise. So
Is it got a narration on it, or is
no, just I don't think so. I think it's solid. It's 16 millimeter, and it's just data film. That we have a lot of cameras on every time we launch something, and somebody just spliced some of those together, and made a little film strip out of it.
Well, it's actually kind of ironic that y'all would watch those for fun.
Yeah. Well, it's people are always asking you about them, So we said, okay, we'll put them all together and let everybody see them. And every now and then, some of the guys would superimpose things. I remember one time we had what we call a countdown demonstration test, And over at the control center, they were monitoring all the stuff on video over there. And of course, the countdown demonstration test, when you reach T0, everything shuts down. Well, somebody had a videotape of an Atlas, and I think this was either an Atlas or a Titan, and they switched it over very quickly, so nobody noticed the switch over. And when it got down to T0, the one on the video screen actually lifted off, and everybody in the control center was not expecting it to lift off, so they all go barreling outdoors to see this rocket that they don't know about going off, because the destruct system's not armed or anything else. They got a loose rocket. Then they go out there and nothing's going on. Everybody laughs at them, of course.
I can imagine. There must have been some startled individuals.
Oh, they always did something like that. You get a new Air Force officer in, you know, and who's really taking his job seriously, and you have to get him trained properly.
Yeah, it must have been special. I remember hearing a story about procedure manuals. Two guys were up on a gantry and they're working and, you know, following it step by step, and Joe falls off the tower, and the guy said, "Wait, you forgot your procedure manual."
That's very true, you know, and then especially it gets involved in all of everybody takes their job real seriously. I know I had an inspector one time. There was some particular task that I wanted done, and he says, "No, we can't do that." I said, "No, you don't understand your job." So we had what we call a mission preparation sheet, and you wrote that, and generally one engineer would write it and another one would sign it, and then when the work got done, you would have one inspector, a contractor inspector would buy it off, and then the NASA inspector would buy it off. So I was tired of something one day, and I said, "You don't know what your job is. Let me explain." So I took a sheet and I said, "Take capsule 14 to the top of the 40-foot tower and drop it." I said, "Now your job is to make sure that it's capsule 14, the tower's 40 feet high, and we indeed dropped it." Because the engineering signature says that's what to do. But fortunately, everybody didn't take it that literally, and if we were going to do something that really would break a spacecraft, anybody could blow the whistle.